What is the minimum cut to estimate the degree of integration? The minimum cut on the system is a way to understand how a system is integrated. And this way to think about the integration through the cut of a system, the minimum cut of the system is actually essential ideas. And this can be applied even outside of a consciousness field or neuroscience or even psychology or anything, really any kind of field that thinks about sort of the degree of the integration or interaction or synergy or cooperation or whatever. And this can be applied even for a team or class or family or any network or whatever really. So how much does the system change if we minimally cut it? That's the question, right? And to find a way or define the minimum cut, that's the question. And in general, if we cut the system randomly, then generally speaking, system changes a lot. But that's not the way we want to test. It's through the identification of the weakest link. That's the sort of the summary. Okay, so let's think about this particular case. 8-neuron system that we considered about TMS-EEG experiment. Here, all of the neurons are connected with others with particular a way like strong or weak connection and bidirectional, and there's just absolutely no way to cut the system in a clean way. It's even difficult to identify where is the minimum cut or weakest link. Okay, so roughly speaking, if after replacing the connection with the noise, and if it changes a lot, that means that there has to be a lot of integration. To estimate how much a system is integrated, we need to find the weakest link and cut there. So if we consider this 8-neuron system that is composed of a 4 completely separated subsystem, and then we identify the cut as this horizontal one, then of course even if we replace this with the noise, because there is no connection to begin with, nothing changes, right? And then this means that the initial thing, right, initial information is exactly the same as the information after the cut. This means that zero integrated information. In IIT terms, it's a bit difficult thing to consider, but this means that this system as a system does not even exist, and that is related to this existence axioms, but I will not go into the detail. On the other hand, if you make a mistake and then cut it randomly like this way, it cuts through the 2 of the subunits, and then if you replace these connections with the noise, then of course the system or this entity will change. But this is basically because we cut it by failure. We didn't cut. If we don't cut the weakest connection, then it always results in the overestimation of the integration, a failure to evaluate integration. And so in other words, here the subset actually does exist. Okay. So now in the next few slides, I'm going to consider this system ABCD or network ABCD, and then to consider what is the minimum cut of the system. And here the rule, as I assume, is that all connections, bidirectional arrow or unidirectional arrow are always a copy. Okay, and then each neuron can take either on state or off state, black or white. And here it's great to just emphasize that it is not in a particular state right now. And then first thing you need to think about is that how many ways are there to cut this particular network or system? What do you think? So you need to think about a way to systematically cut this system into many pieces, or one piece or whatever. But let's think about a way to cut the system into 2. All the possible ways to cut this system into 2. Okay, so let's first start with a simplest kind of possibility. which is a cut that separate one unit from the rest of the three. So the left side is this, A out of, other than B, C, D. And then the second one is a B and the rest, and C and the rest, D and the rest. And then we consider to replace all of these cut connections with a noise. What happens? And then we evaluate which cut is minimal. And then the procedure is that again, replace the connection with the noise and evaluate how it changes the way it constrains the feature and the past, more operationally or more formally. And then, just by looking at this figure, it's quite clear that if we replace any of these three types, then it's going to change a lot, right? Because at least there are two or three bidirectional connections. So if we replace the noise, then the system will change the way it is, both future and the past. And so this will be never minimum cuts. And then, but what about this D to C connection? That's a question. And in this is a connection that is unidirectional from D to C. Okay, and the unidirectional cut doesn't affect how D is going to behave or was informed from past, right? So in general, unidirectional connections do not influence the system a lot. And so that's one thing to think about. Okay, then let's talk about the other three ways to cut the system. And in fact, there are only other three ways to cut the system: AB versus CD, and the AC versus BD, and the AD versus CB. Okay, then it turns out that all of these cuts will definitely change the way the system is. Again, AB versus CD will change a lot because the AC connections and the BC connections are all noise. So that's that screws up all these AB and also CDs future and the past. Same goes for AC versus BD because of the connections between A to B and B to A, B to C to B. All of these are when affected by the noise, it's gonna make a huge difference. And then AD to BC here. Although it's not super clear with this cut system, but the AC connections and also AB connections are affected, right? But the B and C are intactly connected. So this red thing is a bit confusing, but then BC itself as a sort of unit, it's kind of connected like this way. If I replace this connection, so that connection itself is intact, but the AC and the AB connections are disrupted, and that makes a huge difference as well. So in the end, all of these cuts will definitely change the way the system is. And therefore, among the 7 possible ways to cut the system, this D to C connection or C to D connection, which doesn't exist, is the minimum cut in this particular case. So in summary, to understand how the system is integrated, we need to find a minimum cut. And how much does the system change if we minimally cut it? That's a way to evaluate the degree of integration. And searching for a method that identifies a minimum cut is actually quite difficult in general. And when we had this just like 4 neurons or 4 units, it was already like 7 ways to cut it. And you can imagine how much it will be like 10 to the 11 neurons in the our brain. It's going to be really difficult. But having said that, this kind of searching or method to identify the minimum cut is quite a useful thing to think in any network science. And therefore, graph theory or mathematics and even many more advanced kind of theory has been developed to identify the way to do this. And this is a way, one of the active research areas. Okay, so now you presumably understand what it is, but then, okay, if I understand this, what can we explain about the consciousness? And that's next topic in the video.